So today we are going to discuss about interference in thin films. We are able to see colors in soap bubbles as well as colors in oil slicks on a rainy day. What is the reason behind the formation of these colors? The answer is interference in thin films. So let us try to understand what is this interference in thin films. So let us try to first of all answer the question, what is interference? Interference is a superposition of two or more coherent waves. When we say coherent, the meaning is they must have same phase and same amplitude. So now let us consider a thin film whose thickness is T. So this is a oil film. Let us assume it is a oil film of thickness T whose refractive index is mu. So on this thin film, a ray of light is falling with an angle of incidence I. By virtue of division of amplitude, this ray of light now further dividing into reflected ray R1 and refracted ray. Again, from the bottom of this oil slick, it is undergoing reflection and emerging parallel to the first ray R2. So when we look at this picture, it is very clear that the ray 1 and ray 2 are not traveling the same path. They are traveling different paths. So let us try to find out what is the path difference between these two rays R1 and R2. So the first, it is very clear that R2 is traveling extra distance compared to R1. How much extra distance R2 is traveling? So if you see carefully, R2 is traveling an extra distance of AB plus BC in a refractive index of mu. And this R2 is not traveling a distance of AD. So the total path difference in this case is mu times of AB plus BC minus the distance not covered by the ray R2 is 80. So this is our equation 1. Now we have to find out this path difference. So we must know what is the value of AB, what is the value of BC, and what is the value of 80. Let us divide this into two perpendicular triangles, and let me call this as E. Right? Now from triangle ABE, from triangle ABE, cos R is equal to BE by AB. Right? It means cos R is equal to the value of BE, B is equivalent to T, T by AB. It implies that AB is equal to T by cos R. Right? Then let's go for the second triangle. What is the second triangle? Triangle BCE. BCE. Again, cos R is equal to BE by BC. So, cos R is equal to T by BC, which gives BC is equal to T by cos R. Right? So we got what is the requirement? We need AB value and BC value. So now AB is equal to T by cos R, BC is equal to T by cos R. Keep these two values in equation 1. So what happens? Path difference is equal to mu into value of AB is T by cos R plus BC is T by cos R minus AD. So which can be written further as path difference is equal to 2 mu T by cos R minus AD. So this is our equation 2. Now let us find out what is the value of AD. So from this triangle ACD, from this triangle ACD, this is our incident angle I. So what we can write? Sin I is equal to AD by AC. So which can be further written as AD is equal to AC sin I, right? So what is the value of AC? You can write AC as 2 times of AE. So AD is equal to 2 times of AE into sin I, right? From this triangle ABE, triangle ABE, let us go for the value of tan R. So what is tan R? Tan R is equal to AE by BE. So which can be further written as AE is equal to, as you know, BE is equivalent to T, is T tan R. Similarly, other thing what we can write is according to Snell's law, sin mu is equal to sin I by sin R. So this is from Snell's law. What is, we can write this as sin I is equal to mu sin R. So in this AD is equal to AE sin I, we are going to keep the value of AE and we are going to keep the value. So A is equal to D tan R and mu is equal to sin I by R. So sin I is equal to mu sin R. So the value of this AE and the value of this sin I we are going to substitute in this AD. So what happens? AD is equal to how much? To the value of A is equal to D tan R, and instead of sin I we can write it as mu sin R. Mu sin R. So AD is equal to 2 mu T tan R sin R. So this is equation 3. Let us keep the value of equation 3 in equation 2. So path difference is equal to 2 mu T by cos R minus 2 mu T tan R sin R. So tan R can be written as sin R by cos R. So 2 mu T by cos R minus 2 mu T by cos R into sin R becomes sin square R. So we can take 2 mu T by cos R common. So 1 minus sin square R. But you know that 1 minus sin square is equal to cos square R. So path difference is equal to 2 mu T cos R into cos square R. So square and this cos is cancelled. So path difference is equal to 2 mu t cos r. So from this diagram, what is the path difference between ray 1 and ray 2? Path difference is equal to 2 mu t cos r. Another important thing is your incident ray is coming from rarer medium and backed by a denser medium. Whenever a ray is backed by a denser medium, it undergoes a phase reversal of pi or equivalent path difference of lambda by 2. So we have to add plus lambda by 2. So the total path difference in the case of interference in thin film is path difference is equal to 2 mu t cos r plus lambda by 2. Now coming to the conditions. So in this case, we identified the path difference as 2 mu t cos r plus lambda by 2. So we have two conditions. What are the two conditions? First is constructive interference condition. Constructive interference condition. What is that? Path difference is equal to n lambda. So we will substitute this above path difference value in this equation. 2 mu t cos r plus lambda by 2 is equal to n lambda. 2 mu t cos r is equal to n lambda minus lambda by 2. So 2 mu t cos r is equal to 2n minus 1 into lambda by 2. This is the condition for interference in symptoms. What condition? This is the constructive condition. Constructive interference condition. Now the general form of destructive interference condition, path reference is equal to 2n plus 1 into lambda by 2. Again substituting path difference, 2 mu t cos r plus lambda by 2 is equal to 2n plus 1 into lambda by 2. So 2 mu t cos r is equal to 2n lambda by 2 plus lambda by 2 minus lambda by 2. So the condition is 2 mu t cos r is equal to n lambda is the destructive condition for interference in thin film.